Hello, it's now morning, 15th of October. Lovely Sunday morning. We've just had a shower though. Well, this is a continuation of what we did in problem 3, so we know the drill. E12 is of course a modular form of weight 12, and the same with E6, each having leading term unity. So that means the difference must be a cusp form or ein Spitzenform. And therefore it must be C times delta. So it just remains to find the constant, and therefore we need to write up the expressions for E12 and E6. I'll do that while pausing, and then the leading term of delta, of course, and then continue. Delta, here we can see the leading term being 2 pi to the 12th. Oh, we will have to do that in Mabel. And then we should probably factor this guy. That doesn't seem to agree with anything I'm getting here. So I wonder what's up. It's like a plus we should have here. Seven, 6, 2, 0, 4, 8. Three to fifth, 7 squared, divided by 691 q, etc. So this should be the constant except the factor 2 pi to minus 12, 2 to 6, 3 to 5th, 7 squared, right, divided by 691. Wonderful. So that was A. Oops. Well, we need to do it in full detail. And then the double product, it should all have been in parentheses, so that's plus, and then minus 504 squared. And we can collect, like we did in problem 3, to equal powers of q. So the constant terms vanishes, and this should be n, of course. And that means that there we go. That should be the formula for tau of n, the Newton function. I haven't isolated it though. And then we should actually put this constant on the other side. Or should we? I'll just need to think about that, so I'll make a break. The reason for it is that I'm afraid I've made some mistakes, so instead of going on, I'll just go through the computation up to this point once again. As soon as I turned off recording, I could see that I'd forgotten this term. Now my picture vanishes, we'll just have to live with that. So down here we should have this factor. And then part C should be very clear, because we can now isolate tau. Then 699 cancels. Oh, and the constant, of course, is missing here. Plus, and then the sum. We need to compute these numbers, and I'll just do that in Maple. Well, I'll stand by what I get and then write it up. Actually, I can't do that on screen, so I'll just make another break and then write the result. I wrote up the formula. Here. This, of course, is an integer, so let's go modulo 691. That means that, that's weird. Subtracting 691 gives 65. that was just one unity away from what I should give. I believe this is a prime, so we just needed to get the same numbers there. That's a simple error correcting rereading of the entire calculation. So I won't record that. I'll find it, but I will not put it online.